All right, silly people, here's the situation. The quadratic formula, right? This thing that you learned in Algebra 2, you know how to use it. Um, but computers kind of have a hard time calculating like float values for the solutions of these things because subtraction of really large numbers tend to cause issues whenever you put it through a Python code. So I'm just going to work through this problem and explain it as I go. The first part is to write a program that just it takes in three numbers A, B, and C and prints out the the solution to the quadratic formula, right? So I'm just gonna put the code cell here in between this guy and the next problem. Um, so again, it just wants a function that takes in three variables. So I'm gonna create a function called quadratic, and we're gonna have it accept three arguments, A, B, and C. And it's going to return, well, actually, it needs to return an x1 or an x2 because there's going to be two different solutions, right? So the first solution is going to be the minus b plus the stuff. So minus b plus the square root, and then because I need to do a square root, I am just going to import numpy for that as np, because the square root function is nice. And that's b squared minus 4 times a times c, but then it's all divided over 2a. So divided by 2 times a. The other solution is just replacing the plus in the middle there with a minus. So this will become a minus for x2, and we'll have it return a list, because why not, of the solutions, making sure that they come back out as floats, right? And then the problem says test it against the quadratic 0.001 plus 1000 plus 0.001, right? So we're going to print quadratic 0.001, comma 1000, comma 0.001, and see what we get. All right, so it prints out what is essentially 1 to the minus 0.6, right? And also like 10 to the 6. I guess that's 10 to the 7 on the other side. Okay, cool stuff. Thing is, though, the plus solution is going to end up being more close to the actual solution because there's just less subtraction in this solution because it has an addition in here. The subtraction in the square root is going to be given in both, but the fact that this is an addition rather than a subtraction means that that's the more accurate value. And then, so part B is telling us to do this guy. It's just an alternate formation of the quadratic formula with a minus plus on the bottom instead of a plus minus on the top. So, I mean, this is going to take pretty much the same form. I'm going to call the function quadratic alternate. Taking the arguments a, b, and c, and then we're going to print out x1 again, which is now 2 times c divided by minus b minus square root of b squared minus 4 times a times c. Right, same with x2, except x2 is going to have a plus on the bottom. So plus here. And then we'll have the same return line as well. as the last function. And we can try printing out the result of that guy as well. So this is going to be quadratic alt of the same function. So okay, notice how the values differ, of course. Like I said, this is about -1 to the -6, so that's printing out this value now. And again, I said this was about 1 to the 7, or 10 to the 7, I guess. And this is sort of that as well, right? The only thing is now that x2 is going to be closer to the real result because, again, it involves less subtracting. It has a plus on the bottom instead of a minus. The minus is still in the square root, but we can't really get rid of that. So the solution to part C is a program that returns both roots but uses as little subtraction as possible to try and get the most accurate solution, right? So this is going to be called quadratic ideal because it's going to give us the most accurate result, again taking arguments a, b, and c. And then x1, for x1 we use this version of x1 from the traditional form of the quadratic formula. For x2 you use the one from the alternate formulation because it involves less subtraction. And then the return line will be identical to the last two. And we can try and print out as well the solution to this guy. And of course it's going to print out a x1 that matches the first algorithm and an x2 that matches the second algorithm to get the most accurate results. Okay, cool.